Sathyabama Institute of Science and Technology.
Good morning everyone. I am Dr. Nirmala, Department of Mathematics, Sathyabama Institute of Science and Technology, deemed to be University, Chennai. In today's lecture, we are going to see the continuation of Fourier Series. An important topic under Fourier Series is Harmonic Analysis. So already you have studied Fourier Series in the previous lecture. Now, in today's lecture, we are going to see how to expand a function which is defined in terms of numbers, that is numerical value in terms of Fourier series. So, this process is called as harmonic analysis. So, that is the topic of today's lecture. We will see in detail what is harmonic analysis, its application in engineering fields, and how to solve the problem under harmonic analysis. So, let us see one by one. Now, I will define what is harmonic analysis. So, already we have seen Fourier series as an expansion of sine and cosine series in terms of infinite series. So, any function which satisfies certain conditions can be expanded as a Fourier series. Now, in today's topic, we are going to see a special type of function, that is a function which is periodic basically, but defined in terms of numbers. That is, when we have a function f of x which is termed as y, then the numerical values x and y are given in the form of datas. Then in that case, we are going to make use of the decomposition of the function in terms of sine and cosine series using the process called harmonic analysis. Now, let us see in detail where we are applying this harmonic analysis. See, harmonic analysis is vast, having applications in electronics field. Especially, it is applied to decompose complex periodic signals into sine and cosine waves. Also, it is applied to do detailed analysis of vibrations, electrical power systems, sound waves, and other time dependent phenomena. That is nothing but the applications of harmonic analysis. Now, we will see how to apply harmonic analysis when a function is given. So, now we will consider a function f of x which is periodic in nature. In the given interval, we will take a general interval 0, 2l. So, if it is defined like this, then it is possible for us to expand the function as a Fourier series which is given by f of x equal to a naught by 2 plus summation a n cos n pi by l x plus b n sin n pi by l x. Here n takes a value from 1 to infinity. Now, the first term in your expansion is nothing but when n is equal to 1 in your expansion, we will get a1 cos pi x by l plus b1 sin pi x by l, which is called as first harmonic term. Then the second term is when n is equal to 2, we will get a2 cos 2 pi by l x plus b2 sin 2 pi by l x, which is called second harmonic term. And similarly, we have third harmonic, etc. up to nth harmonic term, and it goes on until infinity. Now, in our problem, it is not possible to evaluate all these terms whenever a function is asked to be expanded as a harmonic analysis. So, in our problem, it will be given clearly either to expand the problem up to 2 harmonics or up to 3 harmonics. In that case, what we need to expand is a function whenever given, the first term constant term a naught, which is a naught by 2, plus if it is up to 2 harmonics, then n takes a value 1 as well as n takes a value 2. That is, I need to find the constants a naught. When n is equal to 1, a1, b1, then n equal to 2, a2, b2. So, these are the 5 constants we need to evaluate if a problem comes under up to 2 harmonics. If we are going for up to 3 harmonic, then I have to include the third term also, that is n equal to 3. In that case, the constants which I need to evaluate is A0, then A1, B1, A2, B2, then A3, B3. So, these are the constants I have to evaluate using the formulae which I am going to give you now. So, now you see the formula for calculating the constants. A0 is separate. You see A0 formula, it is nothing but 2 times the mean value of y. What is here y stands for? Y is nothing but your function f of x. So, it will be given in the problem in the defined interval 0, 2L. Whatever interval is given, you take accordingly the value of L from the given interval. So, now here A0 value is nothing but 2 times mean value. Mean value means I have to add all the y entries divided by number of observations. So, sigma y by n, that is nothing but our mean value. So, A1 now similarly we have a general formula for An and Bn. So, now we will see An, it is nothing but 2 times mean value of y cos n pi by Lx, and Bn is 2 times mean value of y sine n pi by Lx. So, in these two cases, if I give n value as 1, I will be getting A1 and B1. If I want A2, B2, then I have to substitute n is equal to 2 in the above general formula to get the second set of terms A2 and B2. And similarly, this procedure will be extended depending on the given problem. So, now we will move on to a simple example problem which will be of different cases. So, I am considering here a problem based on pi, a problem based on degrees, and a problem based on numerical values for x. So, x and y data set will be given always in a problem, and in that problem you will see what x values are. If the x values comes under in terms of pi, then we are going to work out using radians mode. If the x values comes under theta, that is degrees, then you are going to work out the problem under degrees mode, which is a default mode in your calculator. If your x values are in terms of number, again either you can go for pi or in terms of degrees by converting them as we wish. Okay, that case we will see later. So, now we will see as type 1 where the problem, in the problem x values are given in terms of pi's, that is in terms of radians. So, we will go for the first example, evaluation of Fourier series using harmonic analysis. See how the question will be asked is, compute the first 3 harmonics of the Fourier series for the following data set. So, your function f of x is defined like this. So, we will read out the problem very carefully, analyze under which case it comes. Now, you see your x data value. X values are 0, pi by 3, 2 pi by 3, pi, 4 pi by 3, 5 pi by 3 and 2 pi. So, here it is in terms of pi's, that is radians. So, in that case, my first condition to solve the problem is, while using the calculator, convert the mode to radians. So, we know how to convert the mode to radians. So, by using the mode radians, only the problem has to be solved. Then only we will get more appropriate results when compared to other modes. So, we will now first shift to radians mode. Then, the second thing, what we have to note down is, let us see whether the problem is having any similar values. Now, you see the first value and the last value for x, the corresponding y is same. So, when the f of x value is repeated, if it started repeating, then the first period has been completed for the function f of x and it has started the second cycle. As you know very well, we are working with periodic functions, then in that case, we have to consider one cycle or one period for doing the problem. So, since the last value of y is the repetition of first value of y, we ignore the last entry from calculation. So, we are not going to consider the last entry for our calculation because it is the repetition of first y value. Then, third point what we notice, I want to know what is small n value here. Small n is nothing but number of intervals. Kindly make a note of it. It should be a number of intervals. So here the number of intervals is from 0 to pi by 3, 1, 2, 3, 4, 5, 6. So n value is here 6. So in that case, we are going to consider the mean value by finding the summation dividing by n, which is equal to 6 in this problem. Okay. So the important points before solving the problem are, first thing, what is the mode I should consider while using the calculator for solving the problem. If it is in terms of pi, radian mode. Second point is, while solving the problem, I need what is the n value. N value is nothing but the number of intervals. Here it is 6. Now, while solving the problem, from our table, see the last y entry and the first y entry. If both are repeat same, one and the same, then the y entry has been the repetition of last one is the repetition of first one, means then second cycle has started. So, we ignore the last entry and we are going to work out only with the entries till 5 pi by 3. So, now in our question it has been asked up to 3 harmonics. So, we construct a table where we are going to calculate all sines and cosine values for finding the summation. So, just now we see the table how it looks. I have entered all x values. The second column is y equal to f of x. The third column is cos x. Now, if you want, you can include y into cos x as your fourth column, or you complete all sine and cosines, then add y into cos x, y into cos 2x, y into cos 3x for calculating a1, a2, a3. So, this is what we are going to do. Now, for first entry, just we will take the first entry. For x is equal to 0, what is cos x? So, cos x is 0. I have to replace x is equal to 0. So, the first entry in the third column, you see, it is cos 0. Cos 0 is 1. Now, next entry in the next column, sin 0. So, sin x value is 0. So, sin 0 is 0. Then cos 2x. Cos 2 into 0, which is cos 0 again, it is 1. In similar manner, the first row has been filled with the values. Now, the second row, x takes a value, next value pi by 3. So, now x is equal to pi by 3 means corresponding cos pi by 3, that is equal to half. So, in similar manner, all the values has been calculated using radians mode. After filling all the entries in this column, we are moving on to calculate the constants A0, A1, A2, A3 and B1, B2, B3 for finding the Fourier series expansion up to 3 harmonics. So, let us go for the next slide. Now, we are looking for the next slide where we are working for all constants. Now, we will see the first constant. The first constant is A0. A0 value already I have given you in the formula. It is 2 times mean value of y. So, in that case, here it is 2 by 6. As I told you already, n is the number of intervals. So, 2 by 6 into summation y entry. Y entry is your f of x. So, finding its total, we are getting 2.9. Then, now we are going to calculate all ANs. Here, I need A1, A2, A3 up to 3 harmonics. Therefore, I am going to consider only the cosine functions for doing this. So, A1 is 2 times mean value of y into cos x. So, in that case, 2 times mean value is sigma y cos x by 6. So, if I add all the entries and divide it by 6, I will be getting the entry minus 0.37. So, in similar manner, I can calculate A2 and A3. So, after doing all the calculation, I am able to see A0 is 2.9, A1 is minus 0.37, A2 is minus 0.1, A3 is 0.03. Now, for B1, B2, B3, for this set, I need all sine functions. So, again the formula is same. We are going to calculate 2 times mean value of y into, y is here f of x. So, y into sine x for B1. So, when I do that, I am able to see the value is 0.17. And similarly, B2 is 2 times mean value of f of x into sine 2x, which is minus 0.06. Then B3 value is 2 by 6 summation f of x sine 3x, which is 0 here. So, when I calculate all entries, finally we are going to put it in our Fourier series expansion. As the question is up to 3 harmonics, I have to consider leaving a naught by 2 first 3 harmonic terms in my Fourier series. That is the thing, but first term is a naught, which is 2.9. So, here a naught by 2. So, 2.9 by 2 is 1.45. Then a1 is negative. So, minus 0.33 into cos x. Then here a1, then a2, a3, b1, b2, b3 is 0. So, we do not have the last term in our series. So, question is either up to 2 or up to 3. We are going to calculate only that portion alone, and we should not put plus etc. because the question terminates the problem. So, in that case, whatever question is asked, up to the term I have to consider, and I should not put plus etc. Now, we will go for the another example. So, just now we completed one example where x entries are in terms of pi. Now, we are going to see x entries are in terms of degrees. So, let us see the next example. So, second problem, we will analyze the problem clearly, then we will look into the important points, then we will get into the problem. So, first thing is, I have x entries where x values are in terms of degrees. So, 0, 30, 60, 90, etc. up to 330 degrees, and y equal to f of x here, and its values are already given. Just look at the answer. Now, what are the important things I have to consider? First thing is mode of the calculator. Here the values of x are given in terms of degrees, and therefore I have to use the default mode of the calculator, which is already in degrees mode. So, no need to do any change in the calculator. I have to use the default mode as it is. If it is in radians mode, convert back into the default mode, which is degrees, D. Then second point, I have to find out the number of observations, that is number of intervals. Here you can see the number of intervals is 12. Then third one is, I have to find out the degrees here, and one more thing is the last y entry is the repetition of first or not. Here the last entry is not given in this case, that is 360 is not given. Why? Because its value is the repetition of 0 degrees. That is why in the problem itself it has been removed. So, you have to consider the last entry here. In the previous problem, the last entry is neglected because it is a repetition of the first y entry. But here it is not a repetition, because if it is a repetition means then I should have both the y entries to be same. Here y entries are different. In that case, the last entry should be included, and actually the interval of the given problem is 0 to 360. 360 is not given because its value is the repetition of first. So, the overall interval for the given problem where f of x is defined is nothing but 0, 360, which is 2 pi. So, in this case, I have to find out what is L. What is L? The range of the given interval. So, here L is equal to upper limit minus lower limit by 2. So, 2 pi minus 0 by 2 is pi. So, I have to replace wherever L comes pi in the general Fourier series expansion. So, now we will see one by one. Here, the Fourier series expansion up to 3 harmonics again. So, I have to find out the constants till third harmonic term. Now, we will write down the general Fourier series. What is the general Fourier series? F of x or y equal to a naught by 2 plus summation n varies from 1 to infinity an cos nx plus bn sin nx. Now, I have to find out up to 3 harmonics means n equal to 3. Up to 3 I have to consider. So, it is similar to your previous problem. We are going to consider A1, A2, A3 as well as B1, B2, B3 here. So, I am going to calculate using a table, and the table is similar to your previous problem. We have to construct a table where cos x, cos 2x, cos 3x and sin x, sin 2x, sin 3x. So, enter all the values and calculate all the required cells in the problem, and finally we'll be getting all the constants like this. So, now we'll see what is A naught. A naught is 2 times mean value of y. So, y value, if I find out its mean and divide it by 12 and multiply by 2, we'll be getting 404, that is 404. Now, A1, what is A1? A1 is 2 times mean value of y into cos x. So, that entry value here is approximately 107.048. Then A2. A2 value is 2 times mean value of summation y cos 2x. So, it is nothing but minus 13. The next one A3, and A3 value is 2. Similarly, we have to calculate B1, B2, B3. B1 is summation y into sin x multiplied by 2, and its value is 121. The next one we have B2. B2 value is 2 times mean value of y sin 2x. So, in that case it is approximated to 9, and B3 is 2 times summation y sin 3x by 12 because it is a mean value, and its value is minus 1 approximately. So, I am having here all the constant values which are required for doing our expansion, and all the values are non-zero entries. So, every term in your Fourier series till third harmonic will exist. And finally, if I replace all the constants in the general Fourier series expansion, I will be getting the required Fourier series up to 3 harmonics for this particular problem is given as approximately, we have rounded off the entries and we have given. So, y equal to 404 by 2, A naught by 2. So, it is 202 plus 107 cos x plus 13 cos 2x plus 2 cos 3x plus 121 sin x plus 9 sin 2x minus 1 times sin 3x. So, we have seen now an example which is based on x values in terms of degrees. Now, we will move on to the next case. So, this is our type 3 where we do not have degrees, either degrees or in terms of pi, that is radians also. It is somewhat different, and we are going to see how to solve this type of problem also. So, in this case, you see how what is the question and how it is given. So, the values of x and the corresponding f of x values over a period t. So, the period is here a numerical constant t are given below. Show that f of x is equal to a constant 0.75 plus 0.37 cos theta plus 1.004 sin theta, where theta is equal to 2 pi x by t. So, now you see here in this problem, I have to show f of x is equal to this value. So, in this one, I have only cos theta and sin theta. That implies n is equal to 1. So, in that case, I have only the constant A naught by 2 plus under summation n equal to 1 case alone. That means the problem is expanded only up to first harmonic term. So, we are going to solve this problem up to first harmonic term. So, in this one, we will go into the problem. Here he has given f of x is at x is equal to 0, where we have one condition called theta equal to 2 pi x by t. So, I have to put each x value there to find out what is theta. So, the first entry you see, first x value is 0. I am going to put in the relation theta equal to 2 pi into 0. That means theta is also 0. Then go to the next x value t by 6. Put x is equal to t by 6 in this theta relation. T cancel out, you will get 2 pi by 6 which is pi by 3. That is the second entry for theta. Now, replace the third x value which is t by 3. Put x is equal to t by 3, t cancel out, you will get 2 by 3 pi. So, here the third entry is 2 pi by 3. So, in similar manner, each theta value has been calculated and it has been entered here. Now, we have to check all the conditions from here onwards. How theta entries are, it is in terms of pi. And therefore, the first step in our calculator to change your mode to radians. So, the default mode is degrees. I am converting to radians mode as the first step while solving this problem. Second step, I have to see the number of intervals. Here the number of intervals is 6 and therefore we are going to keep n as 6, and again I have to cross check whether the last f of x value is a repetition of first f of x value. Here it is so, and therefore we neglect the last entry from our calculation part. So considering up to 5 pi by 3, we are going to work out for all the entries in the problem. So we are going to now see, after entering theta values, enter your y equal to f of x in the table. The next calculation is, according to our proof asked in the question, I need to calculate only up to first harmonic term. So I want A1 as well as B1. So A1 calculation requires the mean value of y cos x. So in that case, y cos x we need means, first we are going to calculate cos theta, then y cos theta. Then next one, for finding B1 sin theta, then y sin theta. Now we are moving on to each cell value. So first we are taking theta equal to 0 and y value is 1.98. We have entered according to the given problem. Then find out cos theta. So first is cos theta cos 0, which is 1. So in similar manner, I can calculate all the entries in the table and we are able to see finally the constant values like this. So the first constant is A0. What is A0 here? 2 times mean value of f of x. That is 2 times summation f of x by 6, which is 1.5. Then A1 is 2 times mean value of y cos x, which is 0.37. And B1 is 2 times mean value of y sin x, which is 1.004. So, I am going to replace this in the Fourier series, which is up to first harmonic according to the problem, and finally we are getting this to be our result, which is asked in the proof. So, we got the proof and hence the problem has been solved. So, these are the possible different cases under harmonic analysis. While solving the problems, what are the important things we need to keep in our mind is, first step, the radian mode or degrees mode for the given problem. Second step, calculate the number of intervals. Third step, calculate by checking the first y entry and the last y entry. If the first and last are same, then neglect the last entry. If they are different, include it. Sometimes in the problem itself it will be neglected, and therefore we are considering the entire cycle of the given problem as 0 to 2 pi or 0 to 360 degrees or whatever given in the problem. So thank you all for listening the lecture. Thank you.